Let's first investigate the quantum of the decay of the S quark, starting with the electric charge. So we have this generic U quark, which is composed of V rishon, which has an electric charge of 0, and then two T0 rishons, which each have an electric charge of plus 1/3, combining to make the electric charge of the generic U 2/3 plus 2/3. But we know that the S quark, according to the standard model, has an electric charge of minus 1/3. So if we look at this scalar boson, then we see that we have a prime anti-T rishon with electric charge of minus 1/3 and a flavored prime anti-V rishon with an electric charge of 2/3. So for this scalar boson, we have an electric charge of minus 1. And that minus 1 combined with plus 2/3 actually gives us the minus 1/3 we need for the S quark. This particle-antiparticle pair will make no contribution to the electric charge. Now, let's look at the W minus that is emitted. And so we can see that right away that the scalar boson minus carries away a minus 1 electric charge. But in addition, we have a spin 1 vector boson composed of these two V's, but they contribute nothing to the electric charge. Likewise, we have a prime anti-T rishon and a T rishon, making a boson 0, scalar boson 0, that contribute nothing to the electric charge. So the total electric charge carried away by the W boson will be minus 1, which will leave the plus 2/3 on the generic U quark, because this boson 0, of course, will make no contribution to the electric charge. And so we now have plus 2/3 as we would expect to see on the U quark. Now, if we look here at the anti-S, then all of the quanta on these antiparticles will be the opposite of those that are on the S quark. And so the sum of the electric charge on the anti-S, of course, will be plus 1/3 as indicated by the standard model. Now let's take a look at the spin involved in the decay of the S quark. And so on the generic U, we start off with opposite spin quanta on the 2T. So the spin will be given by the V rishon, which is minus 1/2. And if we look at the other components of the S quark, we will see that the spin total will be 0, because these are scalar bosons. And then if we look at the W particle that is emitted, we'll see that we have still two scalar bosons that are contributing nothing to the spin. But here we have a vector boson which has been composed by the exchange of a orange V Rishon for the initial green Rishon. And the green Rishon and then composes with a blue Rishon the vector boson. And so the spin on the generic U quark is changed from -1/2 to +1/2. So therefore the spin now on the U quark is +1/2. And a -1/2 spin is taken away on the W boson. Now, if we look here at the antiparticle, and we can see that the spin on the anti-generic U quark is the opposite. That is on the generic U quark, where it was -1/2, we have now +1/2. So the spin is +1/2 on the anti-S quark. So now let's take a look at the weak charge. And so on the generic U quark as well as the S quark, we had a left-handed spin. And according to the standard model, the spin on left-handed particles, if the spin is for a particle is left-handed, then it must carry a weak charge. And so on the generic U quark, we can see that we have a weak charge of 1/3 and 1/3 on the T Rishon and the V1T Rishon and the V Rishon, giving us 2/3. But then on the other T Rishon, we have -1/6. So the sum will be +1/2 on the generic U. But then if we look at the scalar boson manus, we'll see that we have the weak charges of -1/3 and -2/3, which gives us -1. Therefore, changing the weak charge from +1/2 to -1/2 for the S quark, for the left-handed S quark, which would be correct according to the standard model. And then we will see that a weak charge of -1, of course, is going to be taken away by the scalar boson minus. And scalar boson 0 will make no contribution to the weak charge. But we have a +1/2 carried away on the vector boson. And therefore, we will have a -1/2 spin carried away by the W boson. And if we look up here to now the spin 1/2, the right-handed spin U quark, then we'll see that now we have on the V Rishon, we have a -1/6, and we also have a -1/6 on a T Rishon, combining for a -1/3, and then we have a +1/3 on the T Rishon, and the sum of these will give you 0, so that the weak charge on the right-handed U quark would be 0, as indicated by the standard model. And as before, if we investigate the weak charge here, then we will find that all of the, on the antiparticle, all of the weak charges are the opposite, and so therefore we will get the opposite sums, as we should for a right-handed antiparticle of -1/2.